Hi, I'm John Kinsey, Component Specialist for Rumsey Electric, here to discuss various methods you could use to help improve the reliability of your 24-volt DC power control systems. Next to me, I have a demo box with several components that can help you do this. The first one is a redundancy module. The second component is a buffer unit. The third one is a DC battery-free UPS. And lastly, we have a Bulletin 1692 electronic circuit protector. All of these products up here are parts of the Rockwell Automation Bulletin 1606 power supply product family. Now, let's talk about the redundancy module here. Redundancy modules are used to enable you to tie two power supplies together so that if one power supply were to fail, you would have the other power supply being able to supply power to your load. This is important in critical applications where you don't want a single power supply going down to be the cost of lost production time or potentially in a critical process, potential safety issues. So the way this works is both power supplies are wired into the redundancy module, and power is actually coming from the redundancy module itself. Within the redundancy module are diodes that provide separation between the power supplies. This is important because if a power supply were to experience a fault and they were simply wired in parallel, the fault would cascade down to the next power supply, and the diode protection in the redundancy module prevents that from happening. The other thing that's important about the redundancy module is that you have access to a relay contact in either the relay or the module itself, so that when the power supply faults, you have a signal to your warning system telling you that the power supply has failed so that you could replace it at the next opportunity. Over here in the demo case, we have lights to show you that you have power from both power supplies. The light here shows you that you have power going to your load. So if I was to take power away from one of these power supplies, the light would go out, as you see here, and you could see that you still have power. So that is the redundancy module doing its application when you have a power supply that fails. Next, over here, we have a DC buffer unit, the Bulletin 1606 XL buffer unit that Rockwell Automation supplies. What the buffer unit does is it provides ride-through power in the case of a voltage anomaly like a voltage sag or a spike. Voltage sags are very common and make up about 80% of the voltage anomalies that you experience in a power system. That voltage sag can cause havoc on PLCs, controllers, switches, electronic devices that could trip out in the event of a voltage sag. The buffer unit here provides enough ride-through current so that that will not happen and your DC power is protected. The buffer unit can provide almost 1 second of ride-through current, which is enough time to cover most voltage anomalies that you will see. So let's simulate a voltage sag in this display case so you can see when the buffer unit comes online. I'm going to press this button to momentarily take power away from the power supply. As you can see, the light goes out, but you still have power. And you see this reflected on the device itself with the rapidly flashing light. The unit is buffering. I take my finger off the button, power has returned to the power supply, and all along your control system is still running. Down here, we have a DC battery-free UPS. This can provide up to about a minute's runtime, which enables you, in the case of a power loss, to be able to do a control shutdown. A control shutdown is critical. Imagine, for example, you're working at a computer and you have many applications open and all of a sudden you lose power. You could lose valuable data. In your control system, it's the same thing. You could lose valuable data from your PLC or your industrial computer if you lose power in the middle of an application. The DC battery-free UPS gives you enough time so that you can do a controlled shutdown and protect your data. If you need additional time going beyond a minute, you could use a battery UPS that uses batteries, and that'll give you additional runtime based on how many batteries you use. But of course, when you use battery free, you don't have the maintenance of the batteries, and you also don't have the heat that's generated from them. The DC UPSs with batteries can give you additional run time in the event that you need a longer controlled shutdown that might take, say, 10 minutes. I can simulate what would happen if you lost power with this DC battery-free UPS. I will shut off power to that particular power supply. You can see by the flashing red light and also the light on the panel that this is now giving you enough time to do a controlled shutdown. Controlled shutdown is done. Power is back up, and you can see that the power supply is running again. This is already recharged, as you can see by the steady light, and you're back up and running. The other device in this demo case that could be critical and could help you with your DC power control applications is a Bulletin 1692 electronic circuit protector. What this does is it provides protection for your DC inputs. This unit will protect faster than the power supply has the ability to self-protect. Most modern DC power supplies have a built-in overcurrent protection so that if you experience an overcurrent situation, the power supply will shut down. Therefore, you've lost power to your system. With this Bulletin 1692 electronic circuit protector, this will protect faster than the power supply self-protects, so that you can isolate your loads that are affected to the Bulletin 1692 without losing power to your other devices. This is better than using a circuit breaker, for example, which will only react quickly in a short circuit situation. In a ground fault situation or another overcurrent situation, it may take 30 seconds to a minute for the circuit breaker to trip, but before that happens, the power supply has shut down and you've lost power. I hope those methods are some things for you to think about that can help you in designing your DC power control system. If you have any questions, please contact your representative from Rumsey Electric. Thank you.